Okay, I'll record the second part of the review. This should go pretty quick. Not many problems to do. So these are the problems on S17. I'll begin number 48. We have 3 raised to the x plus 1 equals 9 raised to the 4th. So here the best approach here is to find a common base for 3 and 9. My common base would be 3. So this would be 3 raised to the x plus 1, and 9 is 3 squared, and I need to raise that to the 4th. So we have 3 raised to the x plus 1 equals 3 raised to the 2 times 4 is 8. And so the bases are the same. I can set the exponents equal to each other. And x plus 1 equals 8, so x is equal to 7. All right, that was number 48. 49. We have 32 raised to the x minus 2, which equals 8 raised to the x. Again, I'm looking for a common base for 32 and 8. The only one that comes to mind for me is 2. 32 base 2 is 2 to the 5th, and that would be raised to the x minus 2. And 8 base 2 is 2 to the 3rd, and that would be raised to the x. And so I have to distribute the 5. So this would be 2 raised to the 5x minus 10 equals 2 raised to the 3x. My bases are the same, so I can set the exponents equal to each other and solve. Get 5x minus 10 equals 3x. And then that will give me, move the 3x over, I'll have 8x minus 10 is equal to 0. Move the 10 over, I'll have 8x is equal to 10. Divide by 8, I have x is equal to 10 over 8, which I can simplify. That would be 5 over 4. So my answer is 5/4 for number 49. And then for number 48 it was 7. So 5/4 and 7. Alright, that was 49. Number 50. Number 50, I have 9 raised to the x is equal to 12. I cannot think of a common base for 9 and 12, so we just use inverse properties. Remember, for this case, we use inverse properties, and then we use change of base. So we have to keep in mind inverse functions. The inverse of 9 to the x is log base 9. So I'll wrap everything around log base 9. And so the log base 9 of 12. Well, doing that gets rid of that, because that's inverse relationship, remember? Log base b of b raised to the x is x. Likewise, b raised to log base b of x equals x. So here this gives me x is equal to log base 9 of 12, which we can now use change of base. Okay, so remember change of base, log base a of b, I can write as a set of common logs. That would be log base 10 of b over log base 10 of a. So this I can write log base 10 of 12 over log base 10 of 9. And that would be my final answer. Number 51. Number 51, I have 3.5 raised to 2x minus 1 equals 15. Again, I can't think of a common base for 3.5 and 15, so we wrap everything around that base. We wrap everything around log base 3.5 of 3.5 raised to 2x minus 1 equals log base 3.5 of 15. Okay, so that takes care of that using inverse properties, and I'm left with 2x minus 1 is equal to log base 3.5 of 15. So I'll use change of base to change that to log 10. So 2x minus 1 equals log base 10 of 15 over log base 10 of 3.5. Next step is to add 1 to both sides, so I'll get 2x is equal to log base 15 over log base 3.5 plus 1. Okay, I'm adding 1 to both sides here. And then finally, I'll just divide everything by 2. Okay, so I'll divide everything by 2. And that will be my final answer. Well, let me do this. Okay, and we can leave it in that form. So log base 10 of 15 divided by log base 10 of 3.5 plus 1, and then we divide our entire answer by 2. Okay. So that one was 51. And then 66. This is just making use of inverse properties. So the natural log of v raised to the come back here. The natural log of v raised to the 20 is 20. The inverse of v is ln. Number 67, I have the natural log of e raised to 2x plus 10. That just equals 2x plus 10. 68, I have v raised to the natural log of 5x squared. That just equals 5x squared. And then number 69, I have v raised to 2, natural log of 2 raised to the x. Have to make use of the power property. Move that back up, so that's e raised to the natural log of 2x squared. Okay. And that will just equal 2x squared, which is equal to 4x squared. Okay, so that was it. So for 69, we had 4x squared, 68, 5x squared, 67, 2x plus 10, and 60, number 20. Okay, so that concludes the review. So best of luck on the test. And see you next week.